relief valves. Okay, so kind of like the Flow Max Mooney stuff. This series that we stock, the F70 PR, is 150 class. Okay, so it's going to be obviously relief set points up to 285. They come in body connections, body sizes that are as low as 1 inch and up through 12 inch. So, and it's typically the exhaust is one step up from the inlet. So what we're stocking, like in this particular case, is a 2x3, and we have 3x4s, 4x6s, 6x8s, 8x10s, in some cases 10x12s. And they also make, and they're in aluminum bodies because these are carbon steel, some of the NPT versions, 1.5 by 2. They also have a 2x2, and they all use the same F100 pilot. Very simple, very reliable pilot. Shares some similarities with the Series 20, at least in the way that the springs are. But they tend to have spring ranges for the set points that are extremely narrow, like somewhere between like 3 and 10 pounds. As they go up in relief values, the spring ranges tend to expand out a little bit more and more and more. But FlowSafe's philosophy is to put the spring kind of like right in the middle, right in the sweet spot of its range. And so we carry a lot of springs to be able to accommodate that. They make an F7000 series, which is actually hard to see the difference of, just looking side by side, but this is the cutaway of an F7000 compared to this F70 PR. Where we spec this, we don't tend to carry them, but where we spec this is clearly whenever you have a relief requirement that is higher than 285, and you need body connections that are 300 or 600 class. And so they'll typically be, okay, well, I need a 2x3 relief, but my inlet flange is 600 class, and I want the larger 3-inch outlet exhaust flange to be 150. So all that is accommodated with the F7000 series. They have a couple of other pilot options with those as well, and some other features that they offer as standard, like a backflow preventer. Any of these can have a field test connection that's put on the valve. Basically, it would sit right here. Okay, so there would be a valve right here with a port that would allow you to basically test the valve and check its set point and everything with air, without having to have any gas pressure on the inlet side of your relief. With any of these, basically the size of the piston and the exhaust chamber sets the capacity. So when we do sizing, as an example, if we did an 1.5 by 2 inch F70 PR, it would have the same capacity as the 2x2 because the piston size is the same and the area it has the exhaust to is the same. So that really sets the relief capacity. You can go down to the low pressures below 5 pounds. This pilot that's sitting on here basically changes over, this block changes over to this big diaphragm one. Remember my explanation about the Series 20L pilot? Well, the same thing occurs here, where if I want to get down to, inches of water column set points or up to 5 pounds, then the pilot has this bigger diaphragm. So that's the F70 PR low pressure pilot that would come on the same valve if I wanted to set 3-pound relief type thing. Okay. They're not an ASME coated relief valve. The F7000 series is. So it's another reason why we don't tend to stock them, because we want the ability, if you want us to, if you ask us to basically put the right spring range in it so that we're not waiting for FlowSafe to deliver it in 12 or 14 weeks. So if it's only a matter of changing the set point of the spring, then we're more than capable of doing that for you. And since it's not going to basically have, it's not going to be, wired shut with a set point on it that, if it's changed, does something to your, ASME standard. But we have, where's those springs? Right there. We carry, this is just an example of a couple of different things that go into changing the set point. Typically, below 100 pounds inside this, we won't waste a bunch of time tearing it apart unless you want me to, and I'd be happy to do that. Basically, there's a spacer plate underneath the spring on the low pressure or the lower pressure versions of this pilot. So 5 pounds to basically 100 pounds. It's going to have one type of spacer. But to get up into those like 200, 250 pound set points, the same springs change value by putting a plate underneath basically where that spring case sits and reducing the surface area that the spring actually moves the diaphragm up and down. So these spacers can change the value of the springs just like they change in the value of these black and green springs when you put the high pressure spacer in these pilots. So that same thing is occurring with a FlowSafe release. So there's a lot of similarities there. Some of the things to know about sizing them, because we can do that here in just a second, just go through a sizing scenario. The FlowSafe F100 pilot is going to go off at the set point, but it's not going to provide full relief capacity that's in the sizing charts until it has built up 5% beyond the set point. So we have to plan for that. We have to plan for that requirement for to reach full capacity. It needs to basically go 5% beyond the set point and build up. Okay. Also resetting. It has to have basically to reset and shut off, fully shut off. The pressure needs to drop 5% below the set point. So it has a little bit different characteristics than, say, if we were using a Mooney regulator in the same situation. One of the things that's really nice about this is the design of how the orifice and basically the sealing stem, the sealing plug sits down on that orifice. It's very repeatable. It's basically an O-ring with kind of like the Flowmax, a plug retainer on it, and there's a very defined area where the two make contact, and it is very repeatable. Whereas if you're talking about the plug and stem in a Mooney regulator, the stem, that nitrile plug on the stem in the pilot sometimes can get a kind of like pushed in by a heavy spring for a long period of time as it sits there waiting to relieve. And it kind of gets a notch in it where it's just been pressed in there and sitting there shut off. So when it finally relieves and it goes back to reset, sometimes it has, like a slightly different set point because of that reshaping of that nitrile plug. There's obviously ways around that. The way we get around it is we change the components of what's soft and what's hard inside that pilot cartridge, and they'll put a all stainless steel. Where is that? Oh, here we go. This is just for comparison. So with the Mooney, to get it to do kind of like what the FlowSafe does, we'll use a Delrin orifice instead of a stainless steel orifice in the pilot cartridge, and an all stainless steel plug and stem. So there's no way to deform that. And when it goes in, then it gives you that more repeatable situation when it comes to reset. But that's a nice thing about these, and they're they're high volume. They tend to be less expensive than the comparable, flow grid. If you were going to compare one versus the other as a relief, and like I said, you can get the ASME certification on the F7000 series. Anything above 150 class, that's what we're speccing. Okay, before we go to sizing, does anybody have any questions or want me to open one up or like show you the piston or anything like that inside the body? Or open up the pilot? Nobody? Nobody. Okay.
Jeff, one question.
Yes.
On your for release stack,
Yes.
What do you have so that you keep weather elements out of the stack and things like that? Something that's not going to restrict the flow a whole bunch.
Well, the one thing that the valves themselves do is now they on the exhaust side they'll have a drain where you can get rid of moisture, but you obviously just need to run it up and have a way, a flapper or whatever, to keep rain, weather, and foreign debris out of it. But if it gets moisture in it, it can just be drained out right here on the bottom of the exhaust, right there underneath the piston.
Yeah. I guess I was concerned about the flapper there, in the fact that I haven't really seen good options for the flapper before.
Well, that's something I can look into and get smarter on myself, see if I can't help. But it's not something that we carry right now.
Okay.
But we're always looking for ways, like the heaters and the filters. We're always looking for ways to make regulation and measurement and relief better. So if that's something that we get into, then that's great. We use a local fabricator here in Tulsa to even do more turnkey stuff when someone needs it. Like actually spool pieces for the ultrasonic meters, or building the set, putting ball valves, already just build the skid basically. So we've gotten involved in that just in perspective when someone needs it, and then we can just use all the components in our tool belt to get it done fast. So let's do some flow safe relief. So before I give you that website for flow safe, their sizing program is called Flow Size. Okay, so that's what we're going to go to. Okay, so while he's pulling that up, and you can refer back to this and play with it with the valve spec stuff. But let's just say we have this scenario where we wanted to do a reg relief, a regulator, and then have it covered with a relief. So if we went through that sizing scenario we did before, where we were cutting 225 to 150 with an FG29, and we needed 200,000 cubic feet an hour. When we sized that FG29 for that scenario, basically the top end capacity was 358.2 MCFH. So we need to cover the capacity of that FG29 that we put in place to ensure we had 200 MCFH. So obviously we're covering to what the valve can do, not what our max flow requirement is. So we'll put that information into this flow size calculation, and it starts out where we pick the unit of flow measure, of time. So we're going to do FCFH. Wish they had an MCFH, but they don't. So we're going to have to just literally put in 358 200. That's what we're going to have to cover. And then we're going to go down and make sure we pick the right gas. And so we'll pan down and pick natural gas. And we'll put our set pressure in. We said we were going to try to control at 150. We talked about needing to have a monitor set point that's above that. Let's say it's 155. So let's just say that we're going to use the relief at 160 here. Okay, so if the monitor doesn't hold, then the relief will protect the downstream system. Typically, with an F70 PR, they have as a standard, and they say it's a ASME standard of 10% overpressure plan. And so we'll leave that in place. And then we will calculate. And it already populated, because we picked natural gas, it already populated the right molecular weight, specific gravity, gas constant. All that will change if we pick a different gas. And it gives us a menu of different options that we can now utilize under those process conditions. The first couple are those more expensive ASME F7000s. They're full bore. They don't have a restriction, but they're, like you can see, one's a 150 flange, 1.5 by 3. The other one's a 600 class screwed 1.5 by 3. Then there's an F70 PR that's 1.5 by 2. And then there's the F70 PR 2 by 3 that I actually have on the table. So let's pick that one. Let's use that valve to answer the mail here. So then if I go down to sizing results, it tells me that 2 by 3 F70 PR will flow 697,772.1 SCFH. So let's just call it 698 MCFH. Remember though, that 690 MCFH is at its 5% overpressure point. So when I do my own calculation, I'm taking that back away, because I want to know what the capacity is when it pops off. And then, you know, if I have buildup to my MAOP, you know, then I can take that into account. But obviously that's the objective, is I want to make sure that I protect the system from meeting or exceeding that MAOP. And here's what I'm looking at. I'm taking 5% of that back away, because I don't want to look at it in terms of the buildup, okay? And it also tell me for that valve type what its max pressure is, and we know it's ANSI 150, so it says 285. And then, you know, we can establish a model number associated with this one as well, which when I go back to the board, I could actually write up what that would look like. But it would be a high pressure F70 PR. Why it would be high pressure is because it's above 5 pounds, which is really calling out what pilot I'm going to use. If it's below 5 pounds, it's going to have that big dishpan looking F70 PR low pressure pilot. So that's what it means when it says low pressure, is it has that pilot. So it's definitely going to be the high pressure, and I'd be looking for something that has a ability to get me a spring range in the 160 set point, which is what I want. And if I didn't have that on the shelf, but I had the spring, we could immediately answer the mail getting this out, because all the rest of the stuff about that, the 2 by 3 body, the piston, all the inner components are the same no matter what. Very simple, straightforward. Any questions about the sizing?
So does it always return the 100% value?
Yes, with a relief, I think that's kind of the way it's always thinking you want it, is what's its maximum mobility. It's kind of like when I'm talking to our folks here about, well, people will call in and they were using a flow grid as an example for relief, but they have like a 50% throttle plate in it, or what have you, or a flow safe with some kind of reduced capacity plug retainer. I'm like, well, it's a relief. Its only job is to get rid of pressure that is protecting your downstream system. And it's cheaper anyway not to have all the extra, reduced capacity, whatever, because those always cost money. So just make it relieve as much as it can relieve, and if I can use a smaller one to do the job, but follow that same philosophy, you know what I mean?